In the last part of this exercise, you're going to set up a circuit using the moving coil meter that you've just calibrated to measure the voltage across a resistor and the digital multimeter to measure current through a resistor. And I've just done that using a nominal 10 kilo ohm resistor, plus or minus 5%, and obtained the following results. I set it up and wound up the voltage, and so that there was a 10.0 volt meeting showing on the moving coil meter. I measured 1.33 milliamps of current with the digital multimeter. I've previously calculated the calibration factor for the moving coil meter and measured the resistance of the moving coil meter. Now, as part of this calculation, it suggests the first thing you do is just do a simple-minded calculation of resistance equals voltage over current using the values you've directly measured, and that is just 10.0 volts over 1.33 by 10 to the minus 3 amps, 1.33 milliamps. And if you do that calculation, you'll end up with a value of about 7.52 by 10 to the power 3 ohms, which is 7.5 kilo ohms approximately. Not really near the 10.0 kilo ohms plus or minus 5% we were expecting. Well, the second suggestion was, if we know the calibration factor of the meter, let's work out the true value of the voltage. The true value of the voltage on the moving coil meter is the calibration factor multiplied by the actual measured value minus any zero correction, which in our case was 0. So our calibration factor, 0.8475. The measured value was 10.0 volts. There was no zero error in this case, and so that comes out to be simply 8.475 volts. If we now redo our simple-minded calculation and write R equals V over I, which is now 8.475 over 1.33 by 10 to the minus 3 of an amp, we actually get a worse result, 6.37 by 10 to the 3 ohms, or about 6.4 kilo ohms. About 2/3 of what we were really expecting. Well, what's going on here? It turns out that the resistance of the meter that we're using, the voltmeter, just under 17 kilo ohms, is comparable to the value of the resistor we're measuring. So a significant amount of current is actually going through the voltmeter rather than through the resistor. And so the third method we will use is to write down that correction formula that accounts for the current flowing through the meter as well. So the value of a resistor is the voltage across the resistor over, in this case, the current we measure, which is the total current, minus V over RV. Voltage over resistance gives me current. That term will give me the current that is shorting out through the moving coil meter. If I subtract that from the total current I measure, I will get the amount of current that is flowing through the resistor. So the top line again is 8.475 volts over 1.33 by 10 to the minus 3 minus 8.475 volts. The resistance of the meter, 16.92 kilo ohms, means it's by 10 to the plus 3 on the bottom line there. And working through all of that, I end up with 10.2 by 10 to the 3 ohms, or 10.2 kilo ohms, which is within the tolerance of the resistor, which was rated at 10.0 kilo ohms plus or minus 5%, in other words 10.0 plus or minus 0.5 kilo ohms.